things. In this one, let's talk a bit about graph coloring and something called chromatic number. So this is called chromatic number, which means the minimal coloring of a graph to color a graph so that we don't have vertices. So this is about vertex coloring, namely here we're talking about, and is the minimum number of colors we need for two neighboring vertices at the same edge not to have the same color. So let's talk about some general families of graphs and what coloring they have. So let's take n higher or equal to 2, because that's when it makes sense. The coloring of g equaling some path p sub n, so coloring on two vertices or more, on n vertices in general. What is the chromatic number of it? Well, it's 2, because when we take some path, we have, for example, just the two vertices, we need one color, and then we need another color. So we label this one 1, this one 2. We cannot have 1 next to a 1 again. So this must be 2, but then we can revert back to 1. What is the chromatic number for example, cyclical graphs? There's two options. So there's odd and even ends. There's two options. Let's check it out. If we have, for example, a triangle, an example of an odd cycle, let's color this one. The next one has to be something different. And this one neighbors both. And it neighbors 1 and 2, so it must be a third color. If we expand it to a 4 vertex cycle graph, nevertheless, we can do 1 here and 2 here, and it's fine. The coloring works out. So for odd, it's 2, and for even, it's 3. Let's check it for 5. Here we see, again, we'll have to have the 3, but then we can loop back to 2, and here we can have a 3 again. So we have 3 colors again, such that no two vertices have the same coloring. So these were some initial examples of the chromatic number for both path and a cycle graph. And another one is, for example, tree. We're not going to go into details why that is. The chromatic number of a tree in general is 2. The reason is it works out very similarly like with paths. Whatever tree you take, you can draw it like, for example, this. Let's say we can draw it in this manner. From this one, for example, goes 1, this one also. Let's say this one has more leaves down here, or twigs, and then it expands further and further down. But no matter how complex the tree is, we can always do in this one row, one color. In this second row, it can be all this color, because they're sort of not neighboring by a vertex, by an edge between each other. Here again, we can give it a 1 everywhere. Here again, a 2. And so we see on a larger scale, anytime we look at the path inside this tree, it has this switching between 1 and 2. That's our two colors. We could, of course, use actual colors to color the label the vertices, but if you're not using colors, we can always refer to them by, for example, numbers. That's arbitrary. So this is it. So for trees, we see it's 2 in general.